So I'm going to be drawing on examples from my past experience. In particular, what I'm going to be talking about is my experience across multimodal transport projects. But as you'll note from the sort of summary slide there, I have got a background in other sectors, nuclear and nuclear fusion work. And some of the lessons that I've developed over the course of my career, or learned that I've learned, have come across multiple different sectors, and actually equally apply to all large infrastructure programs, or LIPs, as the term some of you may be familiar with. The key aspect that I really wanted to highlight is that over the last 10 years or so, I've noticed that the environment for large-scale projects has changed. So whereas, say previously, there was a certainty in stakeholders who had a vested interest in the program, and the budgets and the finances available for those programs, the environment outside has changed quite a bit. In the transport sector in particular, it's become a very fragmented industry sector. Whereas, say, maybe even 20 years ago, you might have had Network Rail, a couple of train operators, and a couple of bus companies, and the Department of Transport that you're dealing with. In the intervening 20 years, it's become more and more of a fragmented market, many more stakeholders involved. Local authorities often have more of a voice than national government in the influence and direction of transport programs, which increases the uncertainty and complexity that these projects have to deal with, and also introduces a level of ambiguity, because it's not easy often to identify the relevant stakeholders that you need to engage with, and actually therefore what the outcome for the program should be. And it should be really noted that this is a new normal, not just for transport projects, but also across many other types of sectors as well. So the energy sector, as well, as seeing something very similar in this space. So just to really talk back on a specific element of that, of what the changes that I've seen, I've had sort of highlighted that there are multiple stakeholders that are involved, and two particular projects that I want to talk about in regards to this was my experience working on the Crossrail line, or Elizabeth line as it's now known, which is the new railway line sort of from Reading all the way out to sort of Abbey Wood in the east, crossing sort of central London, and a similar project called Cross River Rail, which is out in Brisbane in Australia, where they were looking at doing an upgrade, an addition of some new stations for a sort of similar type of Elizabeth line project in Brisbane. And it's actually now being extended, where they're actually looking at route extensions. So the main program has been successfully delivered, and they're actively looking at route extensions to the Cross River Rail line at the moment. One thing that most transport projects have in common is that they've recognised systems engineering as a critical enabler for effective and timely delivery, particularly of complex programs where there are many multiple interfaces and stakeholders involved. But conversely, some of the barriers and difficulties that we can see with these is that, due to the number of stakeholders involved, it is possible to have sort of silos forming across the nature of these programs, and being able to have clear articulation of data to share easily with stakeholders, and therefore understand who are the relevant stakeholders that you need to engage and have conversations with is important. So when I was working on the on the Elizabeth line programme, I was working on a particular phase where it was testing and commissioning out at the eastern end of the route at Abbey Wood Station. We were at the phase of the programme where we were trying to close out the construction and go on to the sort of testing and commissioning phases of the work. And the design organization, or the body that was responsible for the design elements, they've transitioned off the program. They've done their handover from preliminary and detailed design, given it over to the construction team for delivery, and usually from their point of view, they don't have any further commercial interest in the program. So one of the issues that we were finding when we were trying to do this transition from construction to testing and commissioning was that there were often vertical integration issues that were coming up with the different individual products that we were doing. So going, looking at installing the track, the signalling systems, getting the trains on board, the signalling systems, the power supply. These had been designed as individual packages, and there was a difficulty in the vertical integration, both in terms of understanding who was delivering what specifically for those packages, but also what was the scope of those particular packages. And within the sort of context of purely a technical conversation, it was pretty easy to sort of identify what was included, but there were differences in terms of program elements. There were differences in terms of who is actually responsible for the piece of infrastructure at such a time, during construction or at testing. When does that handover between the constructor and the sort of testing and commissioning bodies happen? And a lot of that was due to just the amount of information that was flowing back and forth. A lot of information sitting within the technical domain space in terms of physical testing of the systems, a lot of program related information sitting with the program managers around scheduling and timeline of delivery of specific packages. And again, sort of commercial related information about ownership and who held responsibility during the different life cycle phases of the program. And one of the struggles that we had there was actually just being able to very simply and clearly articulate that information. The different sort of package holders held that information in several different ways, whether that was through a requirements management system, whether that was through a BIM model, whether that was through some other type of model that they're using to carry out individual assurance of the work that they were delivering, and trying to get these bits of information to relate to each other so that we could bundle up the individual packages into something bigger for a smooth and seamless handover was quite difficult, actually. It involved a lot of walking around between different stakeholders to try and collate that information together. So by the time I went to work on the Crossover Rail project, the concept of having a system integrator was becoming more well known within the railway industry in particular. And it was about having this overarching body where you have the sort of representation sitting at a slight degree of independence from the main part of the project, but also not only was there that sort of representation from the relevant stakeholders there, but it was also about having a single source of truth for all the data involved in the programs, and essentially trying to create a single repository for all the requirements and assurance information to do with the program. So the approach with Crossover Rail, we actually proposed a model-based systems engineering approach where there'd be essentially a single data source with all of the requirements and interface verification and validation information held in one place, connected to a BIM model, which would hold the sort of construction and assurance related information, and using that to then provide summary reports, which would then be reviewed by the system integrator so that relevant stakeholders could be pulled in to try and support conversations, whether they were program, technical, or commercial related. And another example that I wanted to share in this space was some work that I did for HS2 in the UK. So the HS2 program, many of you probably know, it's been a long time in the making. I I think initial phases of the work kicked off in 2015, from what I remember, but we're now in sort of 2024, and with multiple changes to what the scope of the work is, who's involved, and what's delivering. Um, I was involved in two different phases of this. One was as a technical assurance lead for work happening around the Birmingham side of things, but also a couple of years later, holding a similar role for work happening at the London end of the route. And here, HS2 had a more clearly defined systems engineering, systems integration strategy, but there was still this concern around silos because of the supply chain model that was being used to deliver the program. So we had HS2, the organisation, sitting at the top, and the packages of work were broken down firstly geographically and then by the type of system that was being developed. So with the Birmingham work, I was working specifically on the infrastructure development, the track, bridges, culverts, drainage, that sort of thing. Whereas with the London end, it was one of the packages to do with signalling and electrification, specifically at the London end of the route. So they were both programmatic silos built in due to the geographic breakup of the way of the work, but also commercial setups because it wasn't necessarily one consistent supplier across the whole of the program. You could have one supplier delivering the hard infrastructure at Birmingham, and they could be employed to do station work somewhere else geographically on the route. So again, multiple different layers and intricacies of interfaces within that. That also actually introduced something new, which I hadn't seen before, which was about protectionism of the data that they were generating, because for certain elements, some certain pieces of work, there were some technology which was being protected or unique to the sort of person, the group that was delivering it, which hindered sort of communication, particularly when we were trying to join up along the route for the work. So one area that we explored a bit further with this work was around the introduction of model-based systems engineering. And one of the sort of key benefits that I really appreciate about introducing a model-based way of working is that it removes the language barrier, because you're essentially creating the metadata to represent the system. And that metadata includes all the technical related information, program, commercial, and just enables everything to be captured in one format. It also helped then facilitate interface conversations around functionality, which meant that it was easier to talk around the transition between geographic package boundaries, particularly when we're talking about handover of one signaling system to the next signaling system or one power system to the next power system, and just made it easier all around to identify who the relevant stakeholders were that we needed to engage with on specific conversations. So rather than maybe having quite a high level meeting which engaged all electrification technical leads across the program and HS2, we were able to narrow down and have some very focused conversations by going into the model and using it to filter out the topics for discussion, and therefore who the relevant owners of those interfaces were, and therefore who needed to be invited to a meeting. It helped forming agendas for conversation and helping to record sort of the outcomes of those meetings, so that the outcomes were available for enabling us to not have to repeat ourselves, or for information getting lost in translation as well. Another aspect that was really useful was actually about the engagement of the commercial and program stakeholders, because within the individual packages, those are running on a very specific life cycle for the delivery of those packages. But of course, HS2 and sort of upper layers of the way the program was structured had their own larger life cycle, and in order to help HS2 go back and face challenges that they had to face from the government around through the model was actually really, really helpful, which meant that we were overall improving the response times to questions and engagement of relevant people where questions did come up. And whilst HS2 is obviously quite a large project, I've also applied the approach on several smaller projects. So from sort of my previous nuclear experience, I can sort of really testify to the sort of fact that MBSE as a way of working doesn't just apply to large projects, it also works for small projects and helps really focus on bringing that agility to the delivery of programs. I just really wanted to emphasize another aspect of modelling in respect of migration planning. So this diagram here represents the Transpennine route, which sort of covers central England, so Liverpool, Preston, Bradford, Manchester, York, that sort of region. And Network Rail have been involved in a significant infrastructure upgrade program over the last 6 or 7 years, but looking at updating the infrastructure on the road for the route in red, mainly in producing the track infrastructure, but also with the view of introducing improved signalling technologies and electrification to the route. So that previously that route was a fully diesel route. The benefits of introducing electrification were about being able to improve the flow through of trains, getting more trains through the route, increasing trains available for passengers as well. And in terms of the signalling side of things, there's two major rail routes that run south to north, West Coast Main Line and East Coast Main Line. Both are sort of transitioning to sort of ETCS as a form of signalling, and the idea being that if we could get as well, again, it helps with the scheduling of trains on and off between West Coast and Main Line and East Coast Main Line as well. And whilst the volume of information, technical data, and requirements management was also interesting to manage, Network Rail as an organisation are very much more embedded with a systems engineering way of working, very comfortable with articulating requirements and then taking them through a sort of life cycle to make sure that all the technical assurance is being carried out. What was posing more of a challenge was the migration planning, so more of the program elements related to this piece of work. And conventionally, with a lot of large-scale projects, program information is held usually in a program called P6 or Primavera. But those planning databases essentially tend to be localized. So with this particular route, although on the surface it's Network Rail as one organization delivering this program, Network Rail is actually broken up into regions. So we had 3 separate Network Rail regions covering this route that needed to talk to each other, that had their own programs. We also had multiple train operators covering this route as well, who again had their own program plans in place. And trying to consolidate all of that information together to have a clear overview of what was happening, because of course this wasn't the only program happening on this particular section network at the same time. There were other localized programs happening as well. Trying to build that all in to get a very clear scheduling of works taking place to make sure that resources are being effectively organized, making sure that we could get things done in appropriate timely windows to fit what was happening on the East Coast Main Line and the West Coast Main Line was very, very important. And all the same sort of issues that we were facing earlier applied, but the sort of key difficulty was around the very siloed nature of the program information. And the way forward for this was actually to create a migration plan, which was essentially a holistic perspective on the route, taking the critical milestones and then just creating regular updates for that, which then enabled, again, the articulation of information and the engagement of stakeholders when you should negotiate on different topic areas. So, as an example, one of the topic areas that we had to negotiate around was driver training. Because of the introduction of some of the new infrastructure, there were going to be changes to the cab layout for the driver, and there are also going to be changes to some of the external signage that the drivers would be used to seeing as they drive across the route. In order to develop an appropriate training program for the drivers, we obviously had to have the technical elements agreed by a certain time. We needed to get the multiple train operators in alignment and agreed, and to understand what their priorities were for training, how they rolled out training. And this became quite a big discussion because without drivers, you cannot run a new timetable, essentially. We had some hard and fast milestones that we had to hit for a successful implementation. So this is one area that I really wanted to highlight, because the way we managed this was through multiple different tools, and I haven't yet seen a single tool that could effectively negate the need for multiple databases and having to interrogate and get access to individual databases of planning information. But I think for me, this is really more of a plea around the need to have more open access of data, so that we're not always having to hit the barrier of negotiating with people at every single turn and twist of a conversation. Because there were a couple of occasions on this program where I had to repeat myself due to changes in personnel on a program, and repeating requests for information despite already having secure permission to access particular data sources, which really provided a sort of barrier and a hamper to a timely development of this migration planning. And this really brings me around to sort of the introduction of a systems integrator element to successful delivery. So I'm not expecting you to read this. I'll just make the slides available afterwards. But one of the lessons learned that I took forward from another program, which was actually the importance of not just the models themselves and the data that they contain, but actually having a relevant group of people engaged in understanding the data and being flexible and agile enough to respond to changes in the data that are happening. And this was really sort of shown successfully on the Thameslink rail program, and also work that was being done on the electrification of the Great Western Railway line, sort of out from the west of England up to London Paddington. And I'm not going to spend too much time talking this, but it was just really to emphasize that actually, as well as having good models, good access to data, having a responsive body together within the program who can respond quickly and efficiently to that data really work. The two go hand in hand for a successful delivery. And really, where this led me to was around taking more of a holistic perspective around the management of data, because whilst the programs that I'd been working on up to this point in time were very much focused on responding and being flexible to technical changes and technical management of information, I quickly realised that actually there was a case for taking a more holistic view, an enterprise view of a program, and that actually means thinking about actually how the organization delivering the program is structured as well, because there can be artificial barriers within an organization that hamper free and easy exchange of information. So for me, being able to be successfully implement models comes really top to bottom and bottom to top of how an organization works, why they're there, the rationale for why they're set up in the first place, and the ability and the value of accessing information doesn't just apply at the technical layer or program layer. It also applies all the way through to the top of an organisation and trying to justify why the organisation is there and why they're doing a particular piece of work. And that really came across to me in the work that I was doing at East West Rail, where, similar to the TRU project, it was a railway project looking at new railway line, an upgrade of a railway line between Oxford and Milton Keynes, and then a new railway line between Milton Keynes all the way throughout to Cambridge. And the reason I picked this particular diagram to represent the program because a lot of the conversations that I was getting involved with it wasn't around the specifics of the actual railway line to Oxford to Cambridge. It was actually, why are we doing this? What is the benefit of doing this piece of work? And trying to be able to articulate and understand that having a new station or a new option at Cambridge means that we open up the east of England and improve the economic benefits to the east of England by having the new facility there, the new railway line there, that we can increase freight traffic coming from the east of England, from Felixstowe all the way through to Birmingham and Glasgow, because of the new potential for new freight capacity that the line would open. Being able to access out to the west of England from Cardiff and getting that flow through of people in looking for jobs, and therefore taking that sort of economic benefit out to the west of England as well. And in the context of the work that I was doing at East West Rail, I really wanted to sort of pull together all the lessons that I'd learnt from the previous programs. And I'll just very quickly show this sort of diagram as a sort of summary of that pathway that happened at East West Rail. So initially, when I joined, the organisation was very bought onto systems engineering as a way of working, and in pulling together the lessons learned from my previous experience, I very much wanted to promote the use of model-based systems engineering to centralise the data and the information that we were dealing with. I wanted to introduce the system integrator body to facilitate and manage all of the relevant stakeholder conversations. And I also wanted to have a very clearly defined migration plan to help us sequence all the work and to consider and balance the different priorities of what we were doing. As a sort of offshoot of that, there was actually a view to using the approach to actually look at design, not only of the organisations that would be delivering the railway, but actually of East West Rail as an organisation itself as well. That's kind of the proposal that was put forward and that we tried at East West Rail there. I'm mindful of time, so I'm just going to very quickly go to my concluding slide, which was just really why this approach, why modelling, why having a system integrator. And it's really, for me, about a couple of things: better understanding and articulation of information relating to a programme means that we better understand the type of conversations and the type of collaboration we can have across these programmes, and therefore generate and give better value for what we're delivering in these programs. Hopefully that's I'm more than happy to sort of discuss with you outside of this program as well. But thank you very much